So in this one, we are going to do a problem on limiting reagent, percent yield, and excess reagent. So it's a whole big problem. So the question is, if 4.05 grams ammonia is produced from 2.00 grams of hydrogen and 5.00 grams of nitrogen, what is the percent yield of the reaction? And the second part is, how much of the excess reagent is left over? So it's a two-part problem, okay? And so you have to first figure out how much of the product is going to be produced, and then figure out how much of the excess is left, which means it's a limiting reagent problem as well. So the first thing we do is write the equation. So we have hydrogen and nitrogen reacting to form ammonia, okay? Because as it says, ammonia is produced, which means ammonia is the product. So hydrogen and nitrogen, this is a good example for you to remember that hydrogen and nitrogen are both diatomic gases. So make sure that you write diatomic gases, not H plus N to give NH3, okay? It should be H2 plus N2 to give NH3, all right? And then we go ahead and balance the equation. And in balancing the equation, we need to have 2 nitrogens and then 3 hydrogens, okay, over here. So then our nitrogen that is given to us is 5.00 grams and hydrogen is 2.00 grams, okay? And so we are supposed to figure out the percent yield, okay, which means that we have to find the theoretical yield first, okay? So our answer, okay, begins with theoretical yield calculation, which really is a limiting reagent problem because we have 2 of the reactants given, okay? So let's go ahead and start with 1. So we can start with anything, hydrogen or nitrogen, okay? And so let's start with nitrogen first, 5.00 grams of nitrogen. Again, I'm just going to go ahead and write in the units first. So converting grams of nitrogen to moles of nitrogen, and then doing the mole ratio to find moles of ammonia, okay, from here. So we will stop here, find which one is the lower ratio, and then carry on from there. So in 1 mole of nitrogen, I have 28.00 grams of nitrogen. My mole ratio is coming from the balanced equation, and 1 mole of nitrogen gives me 2 moles of ammonia. And after doing this calculation, 5 divided by 28 times 2 will give me 0.357, okay, moles of ammonia. Okay, that's what I'm forming over here. Now I will do the calculation for hydrogen. And with hydrogen, I'm starting with 2.00 grams of hydrogen. And then I convert the grams of hydrogen to moles of hydrogen. Then I will do the mole ratio of hydrogen to ammonia. And let's fill in the numbers. 1 mole of hydrogen has 2.016 grams of hydrogen, and then 3 moles of hydrogen gives me 2 moles of ammonia. Once I do this calculation, I will get 0.661 moles of ammonia. Looking at these two that I have, 0.357 is the smaller number. Therefore, nitrogen is my limiting reagent, okay, even though it was a larger quantity of nitrogen, but it turns out that it is the limiting reagent. It gets consumed first. I'm going to go ahead and finish my problem right here with calculating the grams of ammonia. So now I will convert moles of ammonia to grams of ammonia, and in 1 mole I have 7.00 grams, okay, of ammonia, 14 plus 3 hydrogens, and this gives me 6.069 grams, okay, of ammonia. So my theoretical yield is equal to 6.069 grams. So my percent yield is my actual yield divided by theoretical yield times 100%. So my actual yield that is given to me is 4.05 grams, and my theoretical yield that I just calculated is 6.069 grams, and then of course multiply that by 100%, and it turns out that I have 66.7% yield. So that is my answer for the first calculation. Now I'm going to figure out my excess reagent. So in excess reagent, I'm going to do this a little bit differently than what I did in class. And so here, what we will do, and actually also in the PowerPoint, okay, it's a little bit different there. So now you get 2 different ways of doing this, is I will start from moles of ammonia, okay, that's what I will do because that's my product. So my excess is 0.661 moles of ammonia, and I subtract the lower amount, 0.357 moles of ammonia. That means I have excess of 0.304 moles of ammonia, okay, this is excess. But this is excess of ammonia, okay, so I need to figure out the excess of my reagent, which if you remember was hydrogen, okay, so which means my strategy is to go from moles of ammonia to moles of hydrogen to give me grams of hydrogen, okay, because H2 is in excess, okay, so that's what I'm calculating for, all right. Okay, so then we take moles of ammonia, which is 0.304 moles NH3 times the mole ratio. So we're calculating for moles of hydrogen, okay, so moles of ammonia goes down here, hydrogen goes up there, and our mole ratio is 3 moles of hydrogen to 2 moles of ammonia coming from the balanced equation. Now let's convert our moles of hydrogen to grams of hydrogen. So in 1 mole we have 2.016 grams and 0.919 grams of H2 is excess, okay, reagent, and that is the final answer for this one. Now to check your answer, 0.919 gram is less than 2.00 grams, okay, that is a cross check. If it is more, then obviously you've done something wrong, okay, because you should not have anything left, okay. So the excess reagent will always be less than what you started with. So that is how you solve for excess reagent.